Hello and welcome to the 8th and final episode for this semester of Delving into Academics. For those who don't know, it's a podcast where various researchers from physics, chemistry and biology are all interviewed about what they're currently researching and also their life as an academic. In this episode, Professor Charles Cockell is interviewed about his life as an astrobiologist and its implications in possibly the future of the human race. So with me today we have Professor Charles Cockell. He did a bachelor's at the University of Bristol in biochemistry and molecular biology in 1989. He then went on to do a PhD in molecular biophysics at the University of Oxford in 1994. From there he went to be a National Sciences Associate at NASA Ames Research Centre from 1995 to 1998. He was then a visiting scholar at Stanford Uni and in 2015 was elected a Fellow of the Royal Society of Edinburgh in amongst various other things, one of which is a director of the UK Centre for Astrobiology as well, and he now is a professor at Edinburgh Uni and teaches some courses. Thank you for coming.
Thank you. No, thank you for inviting me.
Yeah. Let's get started.
Yeah.
What are you currently researching?
Well, we've got a range of projects and they all really focus on life in extreme environments. Microbes is what we're interested in, little one-cell creatures that live in your garden, but they also live in interesting places like deep underground and in volcanoes and asteroid craters. And we're interested in looking at those to try and understand the limits of life. So one of the exciting projects we have at the moment, or at least what we're excited about right now, is a project that's flying to the International Space Station in July, hopefully. It may be delayed a bit, but we're definitely on the next flight. And that's to look at how microbes grow on volcanic rock in preparation for using microbes on the Moon and Mars, for doing biomining or for making soils or for other processes that might use local rock. So we've got little slices of basalt rock that are flying up to space station in some apparatus that we've built, and the microbes grow across the rock, and we study how they form biofilms, layers of microbes on the rock, and how they alter the rock. And they're going to be in the cabin of the space station, which is no gravity, and then they're also going to be in a qubit, which is a mini centrifuge that will simulate Martian gravity and Earth gravity as a control. So that we're very excited about. That's a typical example of an experiment we would do that involves putting microbes in extremes and looking at how they react to different extremes and what we can learn about how life on Earth manages to survive in extremes. What are the limits of our biosphere? Could there be life elsewhere?
Awesome. Yeah, that sounds really cool. And so what do you hope to kind of find from doing these types of experiments?
We hope to learn how space conditions affect microbes and how they grow. For example, if you were to use microbes in a life support system on Mars to sustain astronauts, how would they behave under Martian gravity, other Martian conditions like radiation? But also we get fundamental ideas. I mean, just as an example of a detail, we've observed that one of our microbes grows around the edges of holes in our basalt rock. It doesn't like growing on the surface, it doesn't like growing in the holes, but it likes growing on the edges. So why is that? Is it because there's more energy around the edges? Is it because nutrients are releasing faster from the edges of the holes? So by doing these sorts of experiments, we get fundamental insights. Of course, it's exciting to apply this to space exploration and human space exploration, but we also get fundamental insights into the way life behaves and how life grows on the Earth. So by looking at the microbes and how they grow across the rock, we're learning about biofilms. And biofilms foul industrial plants, they foul your pipes at home, microbes grow in your fridge. So biofilms, these films of microbes, are very, very important in a whole wide range of applications on the Earth. So by looking at how they interact in space conditions, we also get some basic ideas as to how they behave in other contexts as well.
Wow, that's so cool. And I know you're also interested in looking for life elsewhere. So how, from studying these microbes and looking at microbes in extreme environments, how can we then apply that to looking for life elsewhere in other planets?
Yeah, well, I think one of the most exciting science questions that humans have ever asked, and I know when I say this, people roll their eyes. Oh yeah, you've got the most exciting science question. But I still insist that this is one of the most exciting science questions that's ever been asked by the human mind, which is, are we alone in the universe? It's a very fundamental question about what we are and what we're doing on this planet and whether there's anyone else to talk to. And so, of course, at the moment we don't have an answer to that question. We don't know whether there's life elsewhere. But by looking at life on the Earth, we get some ideas as to what are the limits of life. So if you go to Mars, for example, and you find an environment, you could measure the temperature and the radiation and how much salt there is, for example. And you could ask yourself, are those conditions on the Earth that would be suitable for life, or are they outside the boundary for life? So you can think about life as being enclosed in this giant zoo that's surrounded by a fence of physical and chemical extremes. And by mapping out the edge of the zoo, we can then go to other planets and say, do the conditions on that planet fit within the conditions in the zoo, or are they outside? Now, that doesn't mean to say there is life. You could find an environment on Mars that was suitable for life, but it could still be uninhabited. We don't know whether there was any life there to take advantage of these conditions. But the first step is to be able to tell whether a place is habitable, as we call it, whether it can potentially support life. And you can only do that by understanding life on the Earth and by mapping life on the Earth. So looking at microbes in extremes on the Earth informs us about whether other planets could harbour life.
What type of extreme environments are you looking at? Kind of places on Earth, or just...
Yeah, so we have our space experiment, and on the Earth we're looking at microbes in very salty environments, trying to understand how brines affect growth. So one of the things that's quite common in alien environments is salt. On Mars there's a lot of sulfate salts and sodium chloride. And the icy moons of the outer solar system, like Europa, Jupiter's moon, and Enceladus, Saturn's moon, have oceans underneath their surface that we think are quite salty, have a lot of ions in them. So we're doing quite a lot of work in the lab at the moment, trying to understand how ions affect microbes and how they grow, magnesium and calcium and chloride ions and the interaction between those ions, to try and see how ionic conditions affect the conditions for life on the Earth and possibly elsewhere.
Yeah, well, as you said, it's a very interesting question, and the amount of research and what can be applied from just Earth into space.
It's a very wide open question, and although people often think it's a very focused question, is there life elsewhere, it leads in all sorts of directions.
Yeah.
I mean, not just study of life in extremes, but human exploration of space, even sociology questions. Should we contaminate other planets? Is it unethical to put life on a planet that's habitable, particularly if there's life already there? So there are interesting ethical questions. And I think often this question, even though we don't know whether there's life elsewhere, by simply asking that question, it forces us to address other interesting questions. It makes you look at things in a new perspective. And sometimes we find that by thinking about extremes on other planets, we dream up experiments to do here on the Earth that we wouldn't otherwise do. We might look at some strange salts, for example, that are found on Mars and look at how microbes grow in there. But those salts are not found on the Earth. So we learn something very basic and fundamental about how microbes grow. And sometimes going to another planet gives you a very fresh perspective on that you wouldn't have if you just focused on the Earth. So these are the sorts of things that interest us. And quite apart from that, it's just a fascinating question. Is there life elsewhere in the universe? It's just it's a big philosophical as well as a big scientific question, and I just find that a thrilling thing to think about.
Yeah, absolutely, because it's at the same time daunting, and it's kind of like, oh, should we go, curiosity killed the cat, almost. Yes, should we be looking into this, or should we just leave this one? I
think we should, because it's one of the distinguishing features of being a thinking creature. As far as we know, no other species in the whole history of our planet has ever asked, are we alone in the universe? But we know that lots of other creatures eat and sit around wasting their time and just, live a life where they're just existing. So we can do more than just exist. And asking scientific questions and big scientific questions like, are we alone in the universe, is what defines us as a species, and I think is a good thing to do with our intelligence. It may go nowhere, we may end up being destroyed by some asteroid impact, but while we are around, we might as well do something interesting and intelligent with our brains. And I think asking profound questions about the nature of the universe is an exciting thing to do with our time. Even if it's only to use up our time before we go extinct, it's still a good use of time.
Yeah, I completely agree. It definitely is. The fact that we can even go after this kind of questions, and that we have the experiments, like we can think of the experiments that can lead to maybe answers, maybe not, as you say, but it's very interesting, and it kind of is what maybe inspires other people to kind of pursue a scientific career at the end of the day.
I think so. And I think these questions are, they do bring meaning. I mean, on a personal level, they do bring meaning into your life because they're fundamental questions. I mean, I'm not disrespecting other jobs, all jobs that are important in society, but one of the things I find about science is that questions like, are we alone in the universe, or any science question actually, is a sort of fundamental question about the nature of reality. You know, I need a salary like everyone does, but how much money in my bank account is a purely human question. It has no impact on the rest of the universe. So these sorts of things are important, but I personally, and it's just a personal view, don't find them very interesting. Whereas, are we alone in the universe? For some reason, I find that sort of question fascinating because it is something fundamental about the universe we find ourselves in. And so building a career that involves asking scientific questions, for me, is just a personally very thrilling thing to do. And I find it grabs my imagination in a way that I find very little else can do.
Yeah, absolutely. And like, looking towards the future with your current research and then continuing this type of research, where do you see it heading? Like, what types of experiments do you see coming forth?
I think there's there's a short-term future which is carrying on this sort of science, looking at life in extreme environments, understanding the limits of Earth's biosphere. I think on a much wider scheme, this is all really about building a civilization that learns how to live successfully on the Earth, but also becomes spacefaring as well. I think sitting on the Earth for the next few thousand years and going nowhere is not a good idea. I think learning about the universe and moving out into the universe is a good idea for any species that wants at least to try and prevent extinction, even if nothing other than mapping asteroids to prevent asteroid and comet impacts. So understanding the universe around us is important for understanding our planet and what might happen to it in the future. But I also think we learn about the Earth. I mean, in my particular case, in our own narrow area of looking at life in extremes, mapping the boundaries of the biosphere is about understanding what are the limits of life and what happens if you push life over those limits, which is partly about understanding our own impact on the biosphere, the human impact, but also the longer term effects of when, even in billions of years, when the sun warms up and cooks the Earth. Not something we need to worry about right away, but it is part of understanding the future of our planet in the very, very long term. So I think broadly, astrobiology and this sort of area of research is about contributing to understanding our own planet better, and also building a civilization that's capable of moving out beyond the home planet as well, and exploring space and maybe using the resources of space to sustain itself. And I don't think these things are incompatible. You'll frequently come across environmentalists who will say space exploration is a waste of time, we should be solving problems on Earth, and space explorers who view environmentalists as tree huggers who are distracting from their great visions of galactic exploration. But I think the two things are entirely compatible. The Earth is just a giant spaceship with a giant life support system. I mean, even in the 70s, people called the Earth Spaceship Earth. We're just on a giant spaceship. The life support system that sustains us just happens to be this very complex 3.5 billion year old machine. So living on the Earth and living in space is all one and the same thing, and it's learning how to successfully sustain ourselves in the cosmos, whether on the Earth or space. And I think astrobiology is very much the science that's at the core of that, because it's a science that is interested in the connections between the Earth and space in all of its various manifestations, whether it's searching for life elsewhere and looking for life on the Earth, whether it's preparing for the human exploration of space, or learning about the effects of human impacts on the Earth's life support system. All these things fit under astrobiology. And that's why I find astrobiology such an exciting science, because it seems very narrow, and yet actually it's almost problematically broad, because you can address almost anything and you can call it astrobiology, but that's what makes it such fun.
Yeah, absolutely. I think it's those types of sciences which cover such a broad aspect. You can kind of dip into lots of different aspects of it that I also find quite interesting, because I love seeing the connections between things. And I think astrobiology is really science and a area of study that this really shines through.
Yeah, that's right. And things tend to, I think science has got quite focused in the last 100 years. I mean, the thing is, astrobiology isn't new. It's just that 300 years ago, they would have called themselves natural philosophers. I mean, there was a time when science was very broad and people were physicists and biologists and chemists. But that was more because there was so little knowledge that it was easy to grasp lots of areas.
Yeah.
But the point I would simply make is it's not as if we haven't lived in a world where these cross-disciplinary connections existed. It's just that as our knowledge of science improved and became greater and greater, people became physicists or biologists or even neurobiologists or particle physicists. And there's nothing wrong with that. It's to grasp an area in depth, you have to focus. But having said that, there are now many top-level questions, practical questions as well, like, for example, the climate question and the effects of humans on the Earth, that do require connections between disciplines. Biologists have to come together with chemists or with physicists in thinking about going back to space exploration. If you want to build a settlement on the moon, you've got to know about the radiation environment. That's a physics problem. You've got to know how to put people there. That's a biology problem. So many of these grand challenges that humanity now faces do require connections between sciences. And I think it's really sort of thrilling that we now live in this age where we have all this vast quantity of knowledge boxed into different areas of science, but now people are beginning to put these things together again, and the things are beginning to converge. And that's potentially very exciting, because when people were interdisciplinary 300 years ago, they had very little knowledge. Then we moved into a phase where we got lots of knowledge and boxed it into different categories. And now we can take this vast quantity of knowledge and start making connections between them. And that's potentially an immensely powerful stage of scientific development, to be able to link these areas of science together with the vast quantity of knowledge and try and advance the benefit of civilization in its widest context.
It's a very exciting time to be in science at the moment, I think, because of these connections that are happening, and it's being made even easier with the internet now.
Exactly.
And you can just quite easily just connect to all of them, and I think that is where we'll become our most powerful, because we've got such vast quantities of knowledge in each. So to bring them together, it's got to lead to something quite big.
And with all of these things, of course, it can be used in the wrong way, but it's immensely powerful for people who want to use it. And even on a personal level, if you're a scientist, just having access to that knowledge. I mean, I know I write papers and I want to know about something that's completely outside my field, and I just Google it, and horrified though the listener may be, I use Wikipedia. Of course, I check things, particularly if I'm going to put it in a science paper or discuss it in some way. You always check it, but that's the first stop. You can read it on Wikipedia, and it's not bad. Okay, it's always going to have some things that are slightly wrong, and I know from things I do know about that there are always things that are not quite right on Wikipedia, but it immediately gives you some knowledge about the subject that you can then go and look for specific papers and articles within minutes. You can develop some depth of understanding about some point of knowledge that you would have used to have to gone to a library and trawl through books to find a book where it had that bit of information, and then go and find another book. So I think it's also the rapidity with which you can just assimilate knowledge about things, and then not necessarily become an expert, but at least connect it, like we were saying earlier, with other bits of knowledge, and come up with these sort of synthetic ideas that cross boundaries. And I think that's really, really exciting.
And one of the big questions, as you mentioned, that the combination of science can lead to is developing human civilizations in other planets and such. And how far do you think we should go with this? Because I know this is probably me showing my personal opinion here, but some may say we've kind of overpopulated the Earth. And then do you think we should bring that to other planets? And then go and kind of almost overpopulate other planets and keep on expanding? Surely there should be a limit to that.
No,
What's kind of your thoughts on
I don't
that?
think there should be any limit to it. Simply because, except if you find life, if you find life, particularly intelligent life, then clearly there's an ethical boundary there where you should stop, and I think that's very important. But that's why we explore these planets, to find out whether there is life. But any place where there's no life, or where you could show that there was maybe microbial life but you weren't going to destroy it, and we could get into a whole conversation about that. But going back to your general point, I think the more humans there are spread throughout the universe, the better. I mean, imagine a universe in which there are 100 trillion human beings, and thousands of Mozarts, and thousands of Newtons, and thousands of Einsteins, all of which are coming out with genius ideas to make our civilization better. So a large human population is not a problem. It's a problem on the Earth. This is one small speck of rock, tiny speck of rock, orbiting one star. If you start packing in billions and billions more people on this tiny two-dimensional surface on a piece of rock, you're obviously going to have problems, which is what we're finding out. You're going to start changing the planetary atmosphere. So there's no doubt that overpopulation on one rock is a bad idea, but that shouldn't be confused with the general notion of becoming a spacefaring civilization, filling the universe with humans, which I don't think is a bad thing at all. Clearly, when we do move to other planets or move out into space, we also don't want to overpopulate those planets and repeat the problems on the Earth. So locally, people would have to think about in the very, very far future how many people can be sustained on a given planet. So overpopulation is always going to be a problem at the very local level. But the general notion of humanity spreading out into an infinite universe, I think is a perfectly sensible and good objective. I think the more minds there are around, the more ideas we have, the more we accelerate our ability to progress. Of course, it can become quite frightening. We could have so many Einsteins and Newtons that the rate of progress is terrifying, just as it's almost becoming on the Earth. The rate of technological progress at the current time seems to go so quickly, people can hardly keep up. But I think it is. I don't think it's a bad thing for humanity to expand, and it's certainly an insurance policy against extinction as well. If you move out into the universe and you're not stuck on one planet, you're less likely to go extinct. And the dinosaurs discovered what happens if you don't have a space program. An asteroid will get you at some point. It could be in 100 million years, it could be tomorrow, but it will get you. So I think if you've got the intelligence to build a space program and move out into space, and at least try and prevent yourself from going extinct by an asteroid impact, why wouldn't you do that? Why would you just sit on the surface of a planet looking up at the sky waiting for the asteroid to arrive? That just doesn't seem like a very good future to me. So I think we should move out.
Yeah, okay. Yeah, I see that point. That's a really interesting point. And yeah, you're right. It would be really cool to see what having more brilliant minds than we've got now would do for human civilizations in the future. And I did want to ask, how far into the future do you think it would be that would become a spacefaring civilization?
I think building a base that's self-sustaining is quite possible now if we wanted to do it. I think you could build a station on Mars that was pretty much self-sustaining, independently of the Earth, and we know how to do that. So on a small scale, we have the capacity to establish an independent branch, if you like, in its most grandiose terms, an independent branch of civilization on another planet, even if that's just 10 people living in a station. So I don't know why we don't do that, and I think we should do it. How long it would take to become a much bigger civilization spread out through the solar system and potentially beyond, I've no idea how long that would take. It could be hundreds of years, it could be thousands of years. I think the first step, the first most important step, is to establish an independent station on another planet that doesn't require resupply from the Earth. One of the problems with requiring constant resupply from the Earth is it then is attached to the political fortunes of countries on the Earth. If they suddenly shut down the space program or decide it's not high priority, the station will itself shut down. So what you really want to be doing is building a station on another planet that can sustain itself, that grows enough food to sustain itself, and therefore has become independent of the Earth. And that should be our first objective. I think Mars is the best place to do that, just because there is abundant water in the form of ice. There's an atmosphere for protection from radiation. It's probably the most Earth-like world in the solar system. It's still a long way off from the Earth. In fact, it's a pretty awful place to live. About 16 years ago, I wrote a paper called Mars is an Awful Place to Live. So it's a very extreme place. It's not the greatest place to be, but it's the best place we have other than the Earth. So I think that is a good place to focus on building a self-sustaining human settlement.
And how do you think we go about doing this? Like, what would be, I know your research into microbes into extreme environments would help with this. So how would you then incorporate that research into building, as you said, like a civilization branch to Mars?
Well, certainly a lot of the technology exists to build a station and recycle oxygen and recycle water and grow food. Microbes can be used in life support systems, which is something we're interested in looking at. But there's a life support system that's been developed by the European Space Agency called Melissa, which is a fully biological closed-loop life support system where, for example, human waste is broken down and fed to microbes that compost it, and they break it down further, and then that gets used to feed cyanobacteria and plants that produce oxygen, produce food for the astronauts. So these sorts of systems exist. Of course, they've never been tested in space fully, but prototype systems like this exist on the Earth. So it's really about putting all this together and building a station and putting it on Mars, which is easier said than done, of course, because it's expensive, it needs the political will to do it, and getting to Mars is not so easy either, let alone building a station. But the way you want to do it is incrementally. You want to go to Mars and put a small station there that's constantly being resupplied, and you send a mission, say, every 2 years, and you keep adding to it, adding new modules, adding new food processing plants, until eventually you've got the critical mass of technical capability to be independent. I don't know how many missions that would take. I would suspect you could do it in 4 or 5. It depends on the size of the mission, but 4 or 5 missions in, you should be able to have a life support system there and some basic habitats and be growing crops in Martian regolith or soil. So it would take a big effort, but the point is that once you've done it, you have an independent branch of civilization on another planet. And going back to the point I made earlier, something the dinosaurs failed to do, but something we have the technical capability to do. And that's a remarkable thing. After 3.8 billion years, as a species that has not only the ability to think about going to another planet, but actually has the technology to be able to do it. We could do this. So I'm always asking the question, why aren't we doing this? We've reached this incredible point in our development where we could actually go to another planet and build a self-sustaining station. Why would any species sit back and not do that and wait for some unknown future situation to get the motivation to go and do it? I would have thought as soon as you get that capability, you'd be out there building an independent station on another planet. I mean, as an insurance policy, as a way of stepping out into the cosmos. So I don't know what the delay is. I think we should get on with
it. Yeah, absolutely. No, that sounds remarkable, especially if we have the capability to do it. That would then inspire so many people to go into the sciences and just create this whole new era, kind of like the moon landing did back in 1969. So yeah, absolutely. Maybe we should write to the politicians and tell them.
Yeah.
So coming back to the search for life elsewhere, how vital do you think this is in searching for life, or even do you think we should personally go out? Do you think we should maybe send satellites like Voyager out before us and see?
I think we should do both. I think we should send humans. And it's easy to make the argument that you can do all this with robots, and technically you probably can do a lot of exploration just using robots. But I think it misses the point. And it's the point I went back to earlier. We're on this planet. What are we going to do for the next 2,000 years? I mean, what is our purpose as a species? Now, if you're religious, maybe you believe there is a greater purpose ordained to us. I don't happen to believe that. I think we have to create our own purpose. I don't think anyone has given us a purpose. We have to think about what we're going to do for the next, few thousand years. And so I think going out into space is an exciting thing for us to do, rather than just sitting. It's a bit like, a person can sit at home and watch TV and eat pizza for the rest of their life. And you can do that. And some people do it. But it's just not a very exciting thing to do with your one life that you have. And even if going out and travelling a bit and doing an interesting job isn't vital, it's a good thing to do with your life for your own personal fulfillment and because it's interesting. I see the same thing, I think, on a species level. It's a species level thing. We can sit on the Earth and just entertain ourselves, and that's equivalent to sitting in your house watching TV, eating pizza. It's a perfectly acceptable thing to do, but it's sort of boring. There's exciting things to do, and is it vital for us to go into space and explore? No, just as it's not vital for someone to go on holiday to South America or wherever else you want to go and explore on some trek across the Amazon or something. None of these things are vital, but it's enriching and it brings something interesting and fulfilling into your life. And I think when I say your life, I'm now talking about us as a species. What do we want to do with our life, however long that is, whether it's a few thousand years or next 100 million years or even longer? We don't know, just like individuals don't know. You don't know when it's going to end. The asteroid could come tomorrow. So what are we going to do in the meantime? Well, we can sit on the Earth, as I say, and do nothing, and that's okay. But it's sort of boring and it's not very inspired. And I think it's incredibly enriching for us as a species to go out into space, to explore other planets, and to understand the universe. And none of that is vital. There's always going to be problems on the Earth, but it doesn't stop us from doing that. And again, going back to the individual analogy, all of us as individuals have problems, right? We need to find out where our salary is going to come from next, and we worry about, maybe we all have family situations that come up now and again. That doesn't mean to say you never should travel. You should always stay at home ready for the next family crisis or whatever. You can go and do these other things as well. So we have got problems to solve on the Earth, and we should solve those problems. But it doesn't stop us from spending our time doing interesting, fulfilling things like exploring the universe and building stations on Mars and doing something that excites the human imagination and brings purpose and fulfillment to us as a species. So that's how I see it. And I think you can get very much focused on purely the economic argument, and that's certainly an important one. I wouldn't say go and spend 100 billion going to Mars if that's going to materially detract from millions of people getting fresh water. So I don't think you should be silly about this. We shouldn't waste money on going into space when there are serious problems on the Earth. But I think it's a balance, right? We have to continue to solve problems on the Earth, but we can't solve all those problems before going into space, because those problems are always going to be there. So I think we should split our resources, and I think going into space is a really good thing to do. And the question, are we alone in the universe? Again, this is not a vital question for us to answer, but it's a profoundly exciting and important question for us to answer intellectually as a species, if we have any interest in understanding what our place is in the universe beyond our purely everyday existence. And I think we should care about that, because I think it's a tremendously exciting position and privileged position as a species to be in, to be able to ask these sorts of questions.
And I mean, do you think we're alone in the universe, or do you think we will stumble upon an alien civilization, whether it be microbial or intelligent life?
Well, I do think there's a very suspicious, eerie silence, and this is not a new point. I mean, Enrico Fermi is famously known for his Fermi paradox, which is, if there are civilizations out there, surely one or two of them would be older than us. And given our own rate of technological progress, surely then at least a couple of civilizations in the galaxy would have figured out how to travel through the galaxy, and they would visit us every day. So why don't we see aliens every day? There is an eerie silence. What do I think? My view is no better than anyone else's. There's no evidence or data. But if I was to take a wild hunch based on the silence and just propose an idea, it wouldn't surprise me at all if microbes were relatively common, if the origin of life is quite common. But it wouldn't surprise me at all if intelligent civilizations were so rare that they pop in and out across the galaxy, possibly even more than one in one galaxy. Maybe there have been other civilizations, or there are in the Milky Way, but it could be they pop in and out at times that are not compatible with communication, or across distances that are so vast that they would never communicate with each other, even if they were able to make contact and they were at a compatible time. So I can see, in my mind's eye, I have this picture of the Milky Way galaxy with little flashes of intelligence coming and going across the galaxy, but never really making contact. And maybe out there in the universe, there's an intelligence in a dense star cluster somewhere where there happens to be, purely statistically, by luck, a civilization 2 light years away, orbiting another star, and those two civilizations make contact. So maybe there are civilizations out there that really have had first contact and have made contact with aliens, and for them that would be a thrilling and extraordinary thing to happen. But it's quite possible for the majority of civilizations, isolation and silence is the reality of their future, and they will never talk to anyone else, which is sort of depressing. I have an analogy for this, which is again a bit depressing. I sometimes, when I give talks about this, I say to people, I really like to know where civilization is in, say, 300, 500 years' time, but it's unfortunate I'm not going to see it because I'm going to be dead. You're not going to come up to me at the end of that talk and say, you should be more positive about your future. This is ridiculous. You can be around in 500 years. It's not depressing to say I'm not going to be around. At the moment, it's just a reality, unless someone comes out with some immortality technology. And the possibility that we are alone in the universe and will never make contact with another civilization might just be a reality that we've yet to confront. It's not so much depressing, it just might be a reality. And so it could just be that at the moment we're in the Star Trek optimism of our youth, as I call it, where we have these visions of travelling through the galaxy and meeting civilizations and being part of some galactic club. And that's our sort of adolescent enthusiasm about our future. But it could be we are going to hit a brick wall at some point. And as we travel out into the solar system and beyond, we might have to confront the reality that there is no one out there, at least within any reasonable distance that we can ever discover, and that our destiny is to live and die in this region of the galaxy. And as I say, you can call that depressing, but it may end up being a reality. And this is why I go back to my previous point about we should try and find interesting things to do with our time, and like exploring the universe, because there might not be anyone else out there to give us a purpose. We might have to find it within ourselves as to what we want to do with the next few thousand years. If there's no one to talk to, then we have to enjoy our own company. And to do that, we have to find stimulating things to do that are more than just sitting on the earth waiting to go extinct, which I don't think is a very stimulating future.
Yeah, I completely agree with you in all of that. And so is that what you love about being a researcher, the fact that you get to ask these questions and then go out in search of the answers?
I completely love being a scientist and a researcher because I get to think about these sorts of things. In fact, freedom of thought, I think, in a more general way, is one of the things I really value and feel privileged to have working in a university. That no one basically tells me what to do unless apart from the obvious things, which is I need to bring in funding for my research, I need to do teaching, which I thoroughly enjoy. I mean, people do expect something in return for the salary they pay me, and I quite accept that. But within those boundaries, there's an enormous amount of freedom to pursue these ideas and to think about them and to write about them and to do practical research that, I should point out, like we were saying earlier, also has practical applications to the earth. We look at microbes and how they eat cliffs and cause coastal erosion. So do people's houses fall off cliffs because microbes are eating the rocks? So I should point out there's some quite prosaic things that we do as well. And it's important to keep those, despite everything we've talked about, it's also important to keep those practical links to things that are useful in the short term, in terms of paying for that privilege of being in a university and being able to spend your time thinking about these very broad questions. But yes, the joy of science is pursuing interesting questions, discovering new things, trying to find new directions to think about things that maybe people haven't thought about before, and then spending time thinking about these broad philosophical questions. Not all the time. I don't sit at my desk pondering the meaning of life and whether there are aliens out there on a day-to-day basis, but my research gives me the context to think about these things when I do think about them, and that's a very exciting, and a very privileged position to be in, for which I'm very grateful.
Yeah, no, that sounds absolutely amazing. For those in undergraduate degrees currently, but maybe are looking into a career in research later on, do you have any advice for them, or just maybe general advice being an undergraduate?
I think this is a much overused bit of advice, but and it's a cliche, but I would reiterate it because I think it's absolutely true. You want to do something you're really passionate about, something you're really enthusiastic about, because that's really what drives it all. I think it's true of any job, really. To really be motivated to do well in something, it has to be something that fires your imagination. My advice to anyone early in their career is find something that you feel really excited about, because you do only get your one life, and there aren't many things we all get excited about. We all have a few things we get excited about, but there's not an infinite number of things. So when you find something that really gets your imagination going and you think this is really exciting, don't let go of that, because that's a really privileged thing to find, something that isn't just a 9 to 5 thing you have to do because you need to get a salary or something. If you find something you're enthusiastic about and excited about, I would say pursue a degree that brings you close to being able to do that thing. It doesn't have to be exactly that thing. I did medical molecular biology when I was a PhD student, looking at blood clotting proteins, because it wasn't possible to be an astrobiologist. I knew I wanted to do something to do with space, but it wasn't possible to get a job in space when I did my PhD. It just didn't exist. So I went off thinking I was going to do medical genetics, and that would get me into biology and genetics, and then maybe I could think about life on other planets. And then, when I did my postdoc, the postdoctoral position, the NASA set up the NASA Astrobiology Institute, and astrobiology expanded from that point on, and I was lucky enough to be able to become an astrobiologist. But going back to the advice, the only point I was making there was that sometimes you can't do exactly what you want to do. So you have to have a bit of compromise, but find the thing you're really fascinated by, do something that brings you close to that, and then just continue to try and pursue that in life. And often you'll find you can achieve things that you want to achieve if you're enthusiastic. It's amazing how things sort of drop into place if you really want to do something, if you're really enthusiastic. My other bit of advice I would say is never be afraid to ask for help. Now, this is going to sound like a really patronizing thing coming from the sort of the professor, but let me just say this. Older people really like helping younger people, because it's one of the great enjoyments as you get older in your career, is being able to use your position and your knowledge to help other people. I know when I was young, I always looked up at professors and thought, oh, they don't want me pestering them. They've got too many important things. They're just going to think, oh, why is this undergraduate, pestering me? And that's a terrible mistake. Never make that mistake. There will be some old people who will go, oh, why are you pestering me? But don't let that put you off. The vast majority of people want to help enthusiastic young people, because it's a fun and privileged thing to be able to use your position to help other people. Always ask for help, and always go and say, can I work in your lab? How would you suggest I go and get this position? Do you know of anyone who might be able to help me get a job here? And ask relentlessly for advice and help for things, and even for jobs. And you'd be surprised the doors that will open. So that's my other bit of advice. Don't be afraid to use contacts and use people to try and help you advance your career and develop things. So some people always say, it's not who you know, it's what you know. And there's this thing these days, it shouldn't be about who you know, it should be about your knowledge and ability. Sure, it's all about your knowledge and ability, but we live in a society, right? We're a social animal. So there's no embarrassment, and you shouldn't be worried about using contacts and developing contacts, because we're a social animal. If you want to advance your career, go and get to know people and ask them for help. And that's a perfectly legitimate way to develop your own career, and I think it's a very powerful way. I got to know Barry Bloomberg, who was director of the NASA Astrobiology Institute, when I was at NASA, and he was obviously interested in astrobiology, and he was a Nobel Prize winner, and he used to just go out and have beers with the postdocs and PhD students. I didn't actually try to get to know him, I just got to know him because he would go out and have beers with postdocs. And eventually I had to get jobs, and I thought, could I get Barry Bloomberg to write me a reference? He's a Nobel Prize winner. That would be a really good reference. And I was really reticent to do it. And then one afternoon I thought, what the hell? I'll write him an email and ask him. I'm sure he's too busy, but he can only just say no. And I wrote to him, and he wrote me references for several jobs. The Nobel Prize winner. It didn't do me any harm. I don't know whether it did me any good, but I'm pretty sure it didn't do me any harm. That's just an example of, don't be afraid. He was actually delighted to help out. He was delighted to help write letters, and I was obviously very grateful for that help. So that's a very long and rambling way of just saying, ask for help, and never assume that someone is too busy, never assume they're too important. If they turn you down, forget it and just move on, ask the next person, but keep going. It's a good thing to do, and be enthusiastic.
I completely agree with you with both of those points. Yeah, definitely like pursuing something that you're really interested in and like asking for help, because that's kind of what I hope these podcasts are doing, almost giving that people listening that kind of stepping stone, so they kind of realize professors, like what professors are doing, and that they're not that scary.
No,
like,
we probably give the impression of having our heads down all the time and working hard and not wanting distraction. That's only because, you know, when you get to that stage of your career, you have a lot of stuff to do, you know, teaching, writing grant proposals, admin, running a research group. So one tends to give the impression of being slightly aloof and completely absorbed by what you're doing, which is true. But that's not to say we're not easily distracted by, you know, calls for help. And most professors are more than happy to look up from all of their tasks and help people. So I think you're right. You can get the impression that sometimes senior people aren't approachable. I think that's just an illusion based on the sheer busyness of people as they get further on in their careers. But it sometimes hides the fact that a lot of people are extremely approachable, actually, and willing to talk and help and give advice. You just have to ask, but never be afraid. I mean, as I say, that's not to say there aren't some grouchy people out there who might not want to give any support, but that's true of any walk of life. I mean, I find that when I go and ask for advice from people, and that's just a fact of life. So don't let that put you off. And if it happens to you the first time, don't assume that is the pattern of all people. Don't always move on and keep believing that you should talk to people, because it does help.
Yeah. I think the very last question I want to ask you is if you have an inspirational book/article for us to share.
Yeah, again, this is such a boring response. It's a cliche, but The Origin of Species for me is still a remarkable book. And I'll tell you why. And it's not just because, it was written by Charles Darwin and it's really important. I understand all that. I do actually find it a remarkable piece of writing. And there's a few reasons. First of all, because it's beautifully written. It's completely readable. But encased within it is this astonishing hypothesis about how the whole of the biosphere works. If you read it, you realise that it's such a simple idea now, because evolution is sort of taken for granted. Well, actually not taken for granted if you're a creationist, but I think most of us take for granted the broad mechanism of evolution. So when you read it, it almost seems trivial. But when you think about this idea of variation, being exposed to the environment, and some things survive and they go on, that was a radical idea. And what's wonderful about that book is this vast quantity of knowledge that he went out, lots of detailed knowledge he went out and got on the Beagle, and observations he made in Down House and other places. And yet from that vast amount of knowledge he distilled this single synthetic idea, and then writes this book that's written with eminent clarity that anyone can understand, beautifully written, a joy to read, and yet an earth-shattering idea, an earth-shattering hypothesis at the core of all this. So for me, that makes it... There are very few books like that. There are lots of good popular science books that are well written and explain science. There are lots of books that are sort of not necessarily earth-shattering, but have astonishing ideas in them that maybe are not very easy to read. I mean, lots of technical books written by scientists that are very important in their field, but you couldn't just pick it up and read it and find it beautiful reading. And there are lots of books that have ideas that maybe are not earth-shattering, but are just interesting. And there are certainly lots of books that are readable, that are full of lots of details. You can find a biology book that's readable, that's got lots of information about tigers in the savannah, or the life cycle of a seal or something. But to find a book where there's a vast quantity of information distilled into a single idea that's readable, and an idea that changed the world, is extremely rare. And The Origin of Species is one of them. I'm actually trying to think about what another one would be. And now you've asked me, I'm suddenly thinking, what are comparable books in other fields? And I can't actually think at the moment what those books would be, say, in chemistry, physics. Anyway, I'll think about that more after this. But certainly as a biologist, you know, and I think generally scientifically that book is remarkable. And I love reading it. I read it again. Actually, I was writing a popular science book myself about 2 years ago, so I went back and read The Origin of Species that I hadn't read for a number of years. It was just a joy to read again. You can read it multiple times and it's still wonderful to read. So that, for me, is an inspiring book. If you're thinking about becoming a scientist and you want to write a book that will change the world, and you want a template to read just to give you some inspiration about what would be the ideal science book, I think the whole, not necessarily the detail, but the structure of The Origin of Species is the benchmark for any scientist. Simple idea, changes the world, based on a vast quantity of data, so well backed up and beautifully written. You can't really aspire to much more in terms of writing than that.
Yeah, that's absolutely brilliant. Thank you, and thank you for being on this podcast. It's been brilliant.
No,
to talk
thank
to
you. I think
fascinating.
I think it's fun to talk about these things, and thank you for giving me the opportunity to talk about it. And to all the listeners, as I say, keep going with what fascinates you, and keep the enthusiasm going, and that will take you a long way, I think.
Yeah, brilliant. Thank you.
Thank you.
So thank you for listening to this week's episode of Delving into Academics, and I hope you found it interesting. Please like, review, comment and subscribe wherever you're listening to this. And if you want to find out more about the researcher, I will have their university website page linked in the description. See you in 2 weeks for another episode.